Welcome, this is Algebra 2, Semester 1, Unit 4, Section 4.1. We are going to be graphing quadratics. I know that I took you guys through graphing, let's see, absolute values, linears, quadratics, and cubic functions with transitions, transformations, I mean. So these are just a review of those. Again, the x squared will be that U shape, and this 1/2 in front takes the parent graph that goes like this, whoops, like that. It takes that parent graph and it shrinks it down to the x-axis so that where our first point was over 1, up 1, it's now up 1/2. And where our second point was over 2, up 4, now it's only up 2. So it brings it out quite a bit wider than original. Now the domain, of course, on all quadratics, as we discussed before, is all real numbers. The range is your k value, and since it's going up, since it's a minimum, remember mini always smiles, that's a mini because it's the minimum point. Since it's a minimum, our range is y is greater than or equal to, and then our k value, which if you look here, it's plus 0 out here, or there's nothing out here, so it's y is greater than or equal to 0. Okay, our next graph, we do have a k value on this one. So first thing we look at, it's reflected, and the vertex has shifted to 0, 3. There's no h value here, so it's a 0 in there. So it's 0, 3, and it's going to be upside down. It is shrunk again. So rather than coming down 1 over 1 to be upside down, it's going to come down come down 1/2 and over 1. And in place of going over 2 and down 4, it's going to come over 2 and down 2. So it is that wider version upside down. Okay, the domain, all real numbers. And the range, well, because it was reflected, we know that it's less than or equal to. And now we go with the k value of 3. And that should make sense for the graph as well. All the graphing is below the point 3. This one, remember when it frowns, it's the max. Okay. Next one. We have a stretch on this one. We have no h or k value, so we know that its vertex is in the origin. Instead of going over 1 up 1, it goes over 1 up 2, reflected. And then when it goes over 2, instead of up 4, it goes up 8, which we can't even fit in the graph. It's just a real narrow, we say that that's a stretch. The domain again is all real numbers. Because it is not reflected, we know that the range is y is greater than or equal to. And now we go to the minimum point on that, which is 0. Or you can do your k value, same thing. Okay, and that is a minimum. Down to the bottom of this page, hopefully these are beginning to come back to you. We have a k value of -2. No h value, so we know our vertex is 0, -2. And this time, we see that we have the a value of 1/4, which means that it stretches really wide, goes over 1 and only up 1/4. When it goes over 2, instead of going up 4, 1/4 of 1/4 is 1. And so we get this real wide parabola. Okay, the domain again is all real numbers. It is a minimum. And the range, because it's a minimum, it's greater than or equal to. And the k value is -2, or the lowest point on the graph is -2. Okay, This time, we don't have a stretch or shrink, but we do have a reflection. We do shift to -3, so we're down here at -3 with just a normal parabola flipped upside down. Okay, the domain is all real numbers still. And the range is y is less than, since it's reflected, less than or equal to our k value, which is -3. So that one is a maximum. Okay, last one on this page, we have a reflection and a stretch. It's at a negative. The vertex is at 0, 0. The stretch is at a factor of 4, so instead of coming down over 1 and down 1, you would come over 1 and down 4. So even though that looks real thin, it's still over, infinite numbers down here. It will spread as it goes down. So it's still all real numbers. The range, because it's a reflection, is less than or equal to, and the k value is 0. It is a maximum. Okay? Okay, how would you graph each one? Up above on this, I give you the key to look for. Just a few things different. The equations are given in standard form now. ax squared bx plus c. The a, if it's positive, it's a smile, it's still the mini. That's your leading coefficient, just like in the other formula. And if it's a negative, then it's a frown, it's down. Okay? And the a values, again, if they're greater than 1, it's going to be stretched. Less than 1, between 0 and 1 for the absolute value, then it'll be shrunk. And here's how you find the axis of symmetry. Remember, the axis of symmetry is the midline where the graph can fold over itself. That's the midline. You find the vertex by plugging in that value from the axis of symmetry in for your x value and solve for y. Your y-intercept is your c value on the end of that equation. Okay, so first thing here we see, that's our y-intercept, -1. So go ahead and you fill that in down here, -1. Come up to the graph and put a point at -1. Now we have to find our axis of symmetry. If we go up here, there's our formula. I have a lot of students that prefer to remember it as -b over a times 1/2. Okay, so our b value is -2, so it would be a -2 over a value is 1 times 1/2. The 2's will reduce, and we end up with a negative times a negative, which is positive 1 over 1. So our axis of symmetry is 1. Now you come up to the graph and you draw a dark, whoops, it's -1, I'm sorry. No, it's not. It's at +1, I was right. The y-intercept's at -1. Draw a dark dashed line, and at the top of it write a of s. That tells me you found the axis of symmetry, which is 1. We found it again by the formula. Now we take that 1 and we plug it into the equation to get our vertex. 1 squared is 1. Minus 2 times 1. Okay, 1 minus 2 is -1. Minus 1 is -2. So now we can reflect that point and you get an idea of how the graph goes. Okay. We should fill this in. It was -2 with our answer. Okay, next one. Again, standardized form. This is A, B, C. A is actually -1 this time, so be prepared for that. Our y-intercept is 0, c, which is 0, 1. It should be written as a point. I didn't do that on the last one. Okay, 0, 1. So right there's our intercept. We can see right now this is going to be a maximum, so he's going to be coming down this way. Let's find our axis of symmetry. Negative b over a times 1/2. Okay. If we look up here, the b value is -4, a value is -1. So negative 4 over -1 times 1/2. Okay. Negative and a negative cancel. We still have one negative there. 2 and the 4 will reduce. That leaves a 2 on top, so our axis of symmetry is -2. We come up to the graph, and at -2, we put our dashed line and mark that as A of S, axis of symmetry. Now we can also count over and reflect that point from the y-intercept to the other side of that axis of symmetry. All we need to do is find our vertex by plugging -2 in. -2 squared is 4, times -1 is -4, minus -2 times -4 would be a +8 plus 1. So we have a -4 plus 8 is +4 plus 1 is 5. So our vertex is 5 for the y value. So it's a -2, 5. -2, 1, 2, 3, 4, 5. Now if you want to plug in the point in between these, you can. I'm okay if you just do a rough sketch of them. Just check with somebody, make sure that they got the same thing. Okay, the last one. I'd like you to do this on your own. Pause the video, follow the formulas, and then turn it back on to see if you have it right. This axis of symmetry is at -3/2. Our vertex is at -3/2. This is all -1.5. And then our y-intercept is at 0, 3. So it's a very, very steep parabola. Okay, that is the end, I believe. Let me check. Yeah, that's the end of that lesson. Come to class ready to graph those. Mostly work on the standard form. I think that you'll have down the transformation form. Thank you very much.